Okay, the two sample proportion. So I decide to put the rest on only on proportion. In this case, you're gonna have one sample the size n1 and another sample the size n2. We have for a significance level of alpha that will be given to you. And then just like before, we need to know, we got a good idea about something called the Z distribution. Okay, something called population proportion, P. Okay, and something called point estimate, or P hat. Okay, now because you're dealing with two samples, what we have now is something like this. Suppose you got sample 1, I call it simulant A, and the other I call it simulant B. The size for the first sample is N1. The size for the second sample is N2. And then X1 and X2 will be like kind of the results. Let me give an idea. If I say, I would see. A minute, please. Oopsie. Out of 25 students, 12 are from Spain. Okay. Now to look at the p hat, what you need to do is it's gonna be p hat is equal to 12 over 24, something like that, or x over n. Now because we're dealing with two samples, then you're gonna have the first sample you're gonna call p1 hat, the first proportion, and the second sample will be like p2 hat. Okay. Or you can say, for example, out of 21 instructors, and say like 8 are from Spain. It's kind of, we're going to try to compare these two samples with each other. So that will be like P, in this case will be like P2 hat. So let me just put this one as P1, and that will be 8 out of 21. Okay, so that's the idea behind that. There's something the full proportion. This one is like, it's all about the whole picture, like a big picture of everything. Okay, so if you combine example number 1, I mean sample 1 and sample 2, you can say something like this. Just show it to you. You combine both of them together. All right. Combine both of them. So that'll give you something called a p-bar, which is gonna be 12 plus 8 divided by 24 plus 21. Plus 21. What does that mean? If you're not kind of understanding, you can say what they call it. What is the full proportion? It means that out of 24 plus 21 is going to be like 45 people. Then 20 are from Spain. That's the idea. So that's why I call it full proportion. Does anybody have any question about that? Any question?
So the pool proportion, do you typically kind of keep that as a whole number? Or is that you can exchange that into like the decimal form or a percentage?
You put in decimal. Yes, you're gonna have to put in decimal. I'm gonna show a couple examples soon.
Okay, thank you.
Can I keep going now? Okay, so what happened, Jalen? Jalen? Okay. Perfect. So this is what we're gonna be doing. Whenever you have two sample, we need to do also. You're welcome. You need to do also the testing. So first, I'm gonna show the steps. Then I'll give you some examples. Then you can understand better. Okay. So what you just did now is to identify what are P1 hat, P2 hat, P bar, and etc. X1 and 1, and 2 and X2. Okay. So let's go ahead. So the first thing we're going to be doing is to set the claim. How do we set the claim? Somebody, based on the example I just gave you earlier here, I say out of 21 people, 21 instructors, 8 are from Spain. Somebody may say, for example, there's the claim that the proportion, oopsie, just move right here. There's the claim that the proportion give you a minute, I'm trying to make the example. So there's a claim that the proportion of students from France, not Spain, I say, is more than the proportion of instructors. I'm going to leave it generic and it's going to be a lot of redundant, so just to make sure you understand. So the proportion of students from Spain is more than the proportion of instructors from the same country. Okay, so that we're gonna check that. I know that doesn't make that much sense, but what we want to do is just Google generic a little bit, find out, and then we're gonna understand. So we want to test that. The way you do it, the way you put the claim now, because it's like a generalization of what you just say. That's been the proportion from Spain, the population of Spain, like this, probably I will call it P1, is more than those or the proportion of instructors. That's mean on campus you're gonna see kind of see more people from more students from Spain than instructors that are from Spain. That's the idea behind that. So therefore, this is going to be my claim. P1, which is the proportion for students, is greater than the proportion for instructors. That would be my claim. Any questions so far? And as you can see, in the claim, I didn't use any number. Just like I say, P1 greater than 0.5 or P greater than a number. As you can see, just two variables I'm using over there. I just say P1 is greater than P2. Proportion of students from Spain is greater than proportion of students from, proportion of instructors from Spain on campus. Now, the next one will be the claim. Now, the hypothesis. So we have to select one of those. I'm not sure if you guys can see that if the claim is P1 greater than P2, which one do you think would be my hypothesis? Do you think it would be case number 1, case number 2, or somebody already did it? Yes, that'll be case number 3. Thank you. That'll be case number 3. All right. So you're just gonna say HO. So you see, there's no numbers in this one. No numbers. H1. You're gonna say P1 is less than or equal than P2. And then the other one will be P1 is greater than P2. Now my question to you, what kind of tail we will have here? It's going to be a 1 tail, 2 tail? If it's a 1 tail, is it going to be left or to the right? Thank you. It's going to be a 1 tail based on H1. As you can see, the same principle, mainly a 2 tail. No, I'm sorry, to the right. I'll say to the right. Mainly a right tail. Right tail. Okay, thank you. If the alpha is not given to you, by default it will be 0.05. Okay, if it's not given to you, it's 0.05. Now the thing that's gonna change, the only thing that will be changed after the hypothesis, the next thing that's gonna be changed after hypothesis is the statistics. This is how I look. You say Z sub 0 is equal to P1 hat minus P2 hat over the square root of P bar Q bar over 1 over N1 plus 1 over N2. That's the only change. Okay. For example, earlier we had for P1 hat, I think it was equal to, I'm just going to go all a little bit. Give me a minute, please. Let me just go up over here. 12 over 24 and 8 over 21. That'll be 12 over 24. The table, okay. Here we go. The table, which table? Can you speak? What happened to the table here?
The one above it. The one above it. The first one that you showed us.
That's the only table I show you right now. Oh, this
Okay.
one. This one.
That one, that one. Perfect. Okay, that's it. Thank you.
You're welcome. Yes, 8 over 20, 8 over 21. That'd be 2p2 hat. P2 hat. That'll be 8 over 21. Okay. And then this gonna give you, I think, 0.5. If you do the math. And the next one was 8 over 21. Probably gonna give you, see, that'll be 0.38. That'll be 0.38. And then P bar will be, we just did it before, it will be 20 divided by 45. That's gonna give you 144. Thank you. $144. So therefore, I just have to plug in. I will say the first one will be 0.5 minus 0.38 divided by, see, square root of P bar is 0.44. And Q bar, which is 1 minus P bar, that's going to give you 0.56. Thank you. Then the whole thing times 1 over 24 plus 1 over 21. And then close the parentheses. Then this will give you the z sub 0 that you need. And after that, everything else is the same. So the p-value determination, I already give you a table how to get it. Is the same way. The criteria for decision making is the same thing. Nothing changed. The same steps. And the conclusion is the same thing. Okay. So what I'm going to be doing is do a quick example. Something more concrete so that we can understand. So there's no change. So only in that change so far is the way we did the hypothesis and the claim. The hypothesis and the claim are changed because they have no numbers on them. Let me just show it to you. So number 1 and number 2 change because they don't have any numbers. You just say P1 is equal to P2 or P1 is less than P2, whatever it is. Then number 2, also the hypothesis change. And the next one that change is the test statistics, no, it's number, okay, on your formula. Where did I get the 20 over 45? Okay, let me just show it to you again. When I did that problem right here, You see 812 plus 18 over 21 plus 24 plus 21. You see it now? That's going to give you 20 over 45. Okay. You're welcome. So let's do a quick example that is more concrete. For example, this is an example I'm going to give you. Suppose you have a new medication, and then you create a medication, you call it Med A. Okay. Before you put Med A into the market, you would like to know whether Med A is effective. So what we like to do is to give Med A to a group of people and a placebo to another group of people. So it can be two clinics. That be clinic A will get the real medication, and clinic B will get the fake medication. So if Med A is effective, let me just put it down for you. So I'll say, is Med A effective? Right there. That's the question we want to ask ourselves. So if it's effective, that means the proportion of people who took it, I'm going to call P1, the proportion of people who took it must be greater than the proportion of people who took the placebo. Okay, you guys know what the placebo is, right? Yes. So that means that will be effective if the proportion of people who took it is greater than the proportion of people who took the placebo or the fake medication. Usually the medication will be the same color, by the same, by different color of boxes. Okay. So as you can see, when people took the medication, probably after a month or probably 2 months, you give 42 people for a period probably of 2 months, for example. 42 people took Med A, and 41 people took the placebo. Out of the 42 people, the 16 people got better after taking the medication. Probably they say, I'm sleeping very well, I'm fine, etc. While the people who took the placebo, these people, in fact, they think they were taking Med A. Okay, they think they are taking Med A, but they're not taking Med A forward. That's a fake one. That's a fake Med A. Once you took the fake Med A or the sugar pill, 9 people got better probably after 2 months, for example. Okay, again, the example I'm giving you right here, they are generic examples that can apply to any type of situation. Okay, so that's the question. Is Med A effective? As you can see, the proportion of people who took Med A is 0.38, right? And the proportion of people who took the placebo or the fake Med A is 0.22. So my first reaction will be maybe P1 in general is greater than P2. As you can see, 0.38 is clearly greater than P1 at, as you can see, is really greater than 0.22. 0.38 is greater than 0.22. That's mean in general, maybe P1 in general is greater than P2. All right. So if you don't have that specific pattern, like what you just as P1 greater than P2, you will say that Med A is not effective. So we're going to test them together. So what we do, just like we did before, this is my claim. Is P1 greater than P2? Then I put the hypothesis. This is going to be new to you. All right. Then I got my alpha. Then I do the test statistics right here. So when I do the test statistics, I got 1.60 using the formula. Anybody have a problem with that? I'm just showing the way I do it. Then I'm going to let you do one by yourself. So I got 1.60 for the entire thing. Then, because it is a right tail test, as you can see, let me just go up a little bit. This is a right tail. Is a right tail. So my p-value will be 1 minus. Okay. So I do 1 minus p of z less than 1.60, and when I look at in the table, and then subtract from 1, I got 0.0546 as my p-value, and I notice that the p-value is greater than alpha. Okay, so that means my thing will be failed to reject HO. So notice carefully that my decision is failed to reject HO. I'm going to pull this one up a little bit. So go back over there. As you can see, the claim is with H1. So what do we say? I then look at the negative z-score. I look at this one. After this formula, I do 1 minus p of z 1.60. Okay? That's what I look at. This is going to give me a number, and I do 1 minus it. That's the way you should do it, so you have a confusion. So the claim is with H1, and you failed to reject HO. So I think what will be the conclusion, guys? You failed to reject HO, and the conclusion, yeah, the failed to reject HO, and the claim is with H1. What then the conclusion will be? Let me go over here. I failed to reject HO, so do not reject HO. This is HO right here, so do not reject HO. And the claim is with H1. So what I think the conclusion will be? Will be there is enough not enough evidence to support this theories. Okay, you just said there's not enough evidence to support the claim. Okay, Rebecca, thank you anyway. So we have no evidence for the claim. So let's go back over here. So you're gonna say not enough evidence because you say failed to reject HO. Okay, and the claim is with H1. So this is gonna be your result. You're gonna say we have no clear evidence to support the claim that the proportion of population taking med A is greater than the proportion of the population taking a placebo. Okay, we therefore cannot conclude that med A is effective. Okay, because you have no evidence that proportion of the people taking med A is greater than the one taking the placebo, so you cannot say that it is effective. Just like right now, if we have to do medication for the COVID-19, I know it's going to be hard to do it anyway. So there will be anyway people taking some placebo. They will think that taking the medication for the COVID-19, but it's not really the real one. because they are testing those people. So if you go to a specific clinic, they might give you something, and they go to another clinic, probably give you another thing, but probably the medication will have different colors, something like that. So one of them probably is the placebo. Sometimes the doctor doesn't even know which one is a placebo, which one is a real one, and so sometimes the doctor is not even aware that they're making a test on his clinic. Okay, so that's the idea behind our two sample proportion. As you can see, it's exactly the same thing. There's nothing else to do. So just like the only difference we have is that the claim is different, and then the hypothesis setting is different, and the testing, I mean, the test statistics is different. Only two things that are different. I mean, it's just something for you to try to remember, to memorize, because you can also use those notes. I urge you to print those notes, add them somewhere, or on your phone, download the to your phone, so you can do the exam whenever you're taking the next exam. Okay, and beside that, we have a couple examples over there that you can practice. Like example number 2, I put there for you, just like before. This one say equal. If this one say equal, it means that you're gonna have to do 2 tail tests. Okay, and so on. Do you guys have any question for me? As of now, you should be able to do all the questions from the review that I sent you. Any questions? Okay, so if you have no question for me, so this is just basics, the same thing, only 10. So I think this will be to be my last lecture. So I don't have to, and you know, this is, I mean, it might be a stressful week for everybody. So yeah, it's being recorded. So the finals will be this weekend, okay? And then you don't need to log in on Thursday, not Thursday, on Wednesday. So I'll give you that day just to review. If you have any question, you're welcome to email me, and then probably you can request to see me during my office hours online. Okay? So this is my last day with you to cheat. So the test is the 26th is, yes, this weekend. It should be open, you know what? I think it should be open on Wednesday after class. Enough time for you to practice, and then it's going to be open up on Wednesday. Okay? Do you guys want me to open it a bit earlier for you? So you can make sure that you have everything? To probably open it tonight, today, you know? Yeah, lockdown browser. You have to use the lockdown browser, just like before. Okay, I'll open it on Wednesday. So Wednesday should be better. So give you enough time to practice. So Wednesday, we can do it. Okay? So it's coming up on Wednesday. No, it's not due Wednesday. It's due all the way Sunday night. Yeah, from Wednesday to Sunday to do it. So make sure this is not time. Take your time. If you need to leave the lockdown browser, you have to click on the X button to get out. They're gonna give you a reason for you to leave. Okay? Then you can come back at any time. It's not time. The quiz is not time. You have to do it in one sitting. Oh, you know, I'm not gonna answer that question, Stefania. You'll see on Wednesday. Be patient. Yes, you got 2 trials, and I keep the highest of the 2. You don't need to be nervous. You can use your notes. Okay, so have your notes on your phone if you don't have a printer, and then whenever you do make sure you have papers with you, and then a good calculator, and it should be fine. Okay, and that becomes your last exam. All right, guys, and it was good to have you for the entire semester. This is my last lecture with you. Hopefully, I will get the hours this weekend. I'm gonna request for the hours, the extra lab hours, and then hopefully you're gonna have them by Monday. Yes, I will keep it the test. Let me see. No, I will keep the best of the two tests if it's 60 or more. If this one I'm gonna do now is 60 or more, then I'll keep the highest. If not, I'll keep the lowest. No, I'm sorry, if I do the average. Make sure you got 60 or more on that quiz. So I can drop the lowest one for you. No, not from the tutorials. The tutorials is classified. I keep the highest. I'm talking about the previous quiz number 1 and quiz number 2. I keep the highest of the two quiz if quiz number 2 is 60% or more. Okay. All right, guys. It was nice meeting you. Any question, please let me know. We don't do so well. So if you don't do so well, I use the average, quiz 1 and quiz 2. All right, Destiny. No. Whatever quiz 1 is, if you do 60 or more in quiz number 2, I'll keep the highest. That means suppose in quiz 1 you had a 50, okay, and then in quiz 2 you have 80. Then I'll keep the 80. It's evidence even on quiz 2. No, it doesn't matter the test. Whatever the test is the quiz now. Okay. Okay. Have a good day too. Yeah, this is my last class right now. I'm not gonna teach anymore. I'm finished with all the lecture. Okay, Maria, don't you want to have a day off? I have another question. Yeah, go ahead. It's about it. Great. Oh, your total is 109.9. Oh, okay. I'll double check on that. You're not supposed to have the total grade anyway. I don't know why you have it. Because why we got everything correct. I'll fix that. Okay, this one I'm gonna be doing also. Let me see. One is the personal homework too. Everything is due on Sunday. Everything is due on Sunday. Yes, no, the 25% is mainly your attendance coming to class here. It might happen that I drop the grade for Pearson if it's a problem for you, for everybody to fail. Yes, Pearson might be dropped. If it's gonna cause you to fail the class, it's gonna be dropped. Even though if it causes you're going to go too low, I might drop it. Okay. Right now, do whatever you can. Keep working on it so you can get the highest as possible. All right. No, not necessarily. I'll look at the overall grade only. Just the overall grade. Whatever you do overall. Which lab? The lab hours is extra credit. The mastering. Is that in Pearson? No, Pearson is okay. Pearson is if it causes you to fail, I'll just drop it. If it's the lowest, it's gonna be dropped. All right. Okay, so the quiz will be ready on Wednesday around this time. Okay. What happened, Maria? You want to tell me something? Maria? Okay. Thank you. Have a good day. You too. Thank you very much. You too, guys.